Hi everyone. This is example 7 from chapter 12 in the student packet. And I want you to contrast this example with example 6. So we have the same box of marbles that we had in example 6. And I wrote down the specifics over here. We had 7 red marbles, 3 green marbles, and 6 black marbles. But this time, after we draw one marble out of the drawer, we do not replace it before we draw the next marble, and this is called without replacement. So now for part A, it says, are drawing marbles without replacement independent events? And in this case, the answer is now no, because the probability of the next draw is affected by the first draw or the previous draw. So there is a formula for doing these types of problems, and I'm going to write it down on the bottom in yellow. And that is if we have the probability of A and B, where A and B are not independent, then this is going to be the probability of A times the probability of B given that A occurred. Now, I'm going to emphasize that in this case especially, you should not be trying to memorize this formula. Instead, I want you to think about these problems more logically and imagine actually drawing the marble out of the drawer, since we have a concrete number of marbles. So for part B, it says first the probability of drawing, find the probability of drawing 2 black marbles in a row. So we are going to find the probability of drawing a black and then another black. And in this case, we are finding the probability of drawing a black times the probability that we're drawing a black given that we already drew a black marble. Again, I'm writing way more than you need to write for this problem. Instead, I want you to think about this in terms of fractions. So what is the probability of drawing a black marble the very first time around? Well, we have a total of 6 black marbles and a total of 16 marbles overall. So that's the probability of drawing the first black marble. So now we drew a black marble out of the drawer, which means that now there are only 5 black marbles left. And since we drew one marble out, the total marbles left are now 15. So slightly different from what you did in part B in the previous example, in that we had to reduce the number of black marbles and reduce the number of marbles overall. And this is going to give you 0.075. Now let's do part C. Find the probability of drawing 1 green marble and then 1 red marble. So we're going to find the probability of drawing a green and a red. Again, using the formula, which you don't have to do, but I'm just doing it for completeness sake, this is the probability of drawing a green times the probability of drawing a red given that you already drew a green. Well, what's the probability that we draw a green? There's 3 green marbles out of 16 at the very beginning. So that's our first draw. And now we drew a marble out of the drawer. We drew a green marble out of the drawer, which means we only have 15 marbles left, but we drew a green marble, which means it did not affect the number of red marbles that are left. So that stays at 7. And when you take 3/16 times 7/15, you're going to get 0.0875. For part D, it says find the probability of drawing 1 red marble and then 1 marble that is not red. So the probability that we're going to draw a red marble and a not red marble. So again, I'm just going to completeness sake here, I'm going to write this out, but you do not have to write this out. Oh, that's wrong. Let's try this again. There we go. So what's the probability of drawing a red marble? Well, we have 7 red out of a total of 16. We drew a marble out of this drawer, which means that we only have 15 marbles left. How many not red marbles do we have? Well, we have 3 green and 6 black. And the first draw was a red marble, so we did not draw a green or a black, therefore the total number of green and black did not change. It's still 9. And when you put this in your calculator, we get 0.246.